Looking up at the night sky, you'll typically find thousands of stars spread out in an evenly uniform fashion. But the scenario is a lot different when you look through the eyes of a telescope. You would never know there are empty zones in space, no stars, no galaxies. But recently, the phenomenon seems to be getting worse as James Webb Telescope revealed that more stars are disappearing. Join us in this video as we explore the mysterious phenomena of space voids and cold spots and the various explanations scientists have come up with as to why our stars keep mysteriously disappearing. The universe has always intrigued mankind. The effort to understand its dynamics and various complex components prompted the creation of human endeavors like cosmology and astrology. Understanding the various parts of our universe doesn't only give us a clue about the future, but also helps us explain the past. Thanks to the study of the planets, stars, and galaxies, scientists have put up profound theories to explain why so many things on Earth are the way they are and how things were before we got here. But even with all the phenomenal breakthroughs, numerous mysteries still remain unsolved. Some of these mysteries rattle the very core of cosmology, making us question all we'd learned so far. One such mystery is space voids. The skies are filled with stars, at least that's the view from Earth. But up close, scientists have noticed some patches in our universe, places you would find little or no stars at all. These parts of the universe look as though several galaxies have vanished from them. Ever since their discovery, scientists have kept scratching their heads, trying to decode how a cloud of stars or galaxies could just disappear. So far, it's only led to more questions and even stranger discoveries. You see, the space voids are very similar to the Great Unconformity. The Great Unconformity is a geological mystery that has left scientists with more questions than answers. It is a gap in the Earth's geological record. It is believed to be a time lapse of 100 million to 1 billion years. There is no recorded evidence of geological activity on Earth for this period. So it's like the Earth magically skipped millions of years in its evolution. And nobody has any insight into what happened. All we have is proof that something of this sort occurred some time ago. The Great Unconformity is spotted in various rock sections around the world. The majority of the rocks from this period show signs of weathering and erosion, indicating that they've been exposed to weather elements for a far longer time than most rocks on the Earth. One of the theories that have attempted to explain this anomaly proves that the Earth underwent extreme weathering and erosion, which removed nearly all the existing rocks of that period. Another theory suggests that the Earth suffered from a massive tectonic event which led to the destruction of the existing rocks and the formation of new ones. Neither of these theories has proven satisfactory enough, and just like this great anomaly, the Great Void has been another hard nut to crack. The Great Void is a massive region of empty space in the universe that we aren't quite sure how it came about. As we mentioned earlier, there are several voids in space, regions where billions of stars or even entire galaxies have disappeared, entirely empty of galaxies and stars. The voids in the universe were first discovered in 1978 by Stephen Gregory and Laird Thompson. The width of the Great Void is estimated to be about 330 million light-years across. It was discovered in the Bootes constellation. To give you a perspective, the distance between our Earth and the closest star is about 4 light-years. So imagine something that's millions of times bigger than that distance. The Great Void is not completely empty, as the name may suggest though. It still contains an almost negligible number of galaxies compared to other regular parts of space. After years and years of demystifying this natural phenomenon, scientists finally began to formulate a couple of theories to explain it. One of the common theories is that this void was caused by a primordial black hole. If you're a true lover of space and cosmology, you'd already know what black holes are. Black holes are spots in space with a very strong gravitational pull that sucks in anything that gets close. They are usually created when giant stars collapse. However, this school of thought assumes that the kind of black hole responsible for the Great Void is a primordial black hole. Primordial black holes are black holes that formed during the early moments of the universe's creation after the Big Bang. In theory, these black holes may have started as tiny quantum fluctuations, but then they grew larger as the universe got older and expanded. And so, in the process, these primordial black holes could have swallowed up everything around them, leaving behind a massive void. This theory at first seems quite sound, given the fact that we've seen how overwhelmingly destructive black holes can be. Not even light can escape this space phenomenon. But still, it seems far-fetched that a black hole could swallow up whole galaxies. Besides, if a primordial black hole is responsible for this great void, does it mean then that non-primordial black holes are responsible for other lesser voids scattered all over space? Well, that's the hitch in this theory. Another viable theory that explains the Great Void is that of cosmic strings. Cosmic strings are hypothetical objects believed to have formed during the dawn of the universe. Scientists believe that these strings may have interacted with matter and gravity in strange ways, promoting the separation or isolation of matter from them. This separation or isolation may have then led to the black voids we see today. A third theory believes that cosmic variance is the reason for anomalies like the Great Void. Cosmic variance is the belief that there are variations in the universe by default, and so everything isn't entirely uniform all through. This theory is held in high esteem because, in truth, the universe is not uniform. Some regions are more packed with stars, asteroids, and galaxies than others. However, accepting this theory would mean accepting that we've gotten to the end of our discovery, and so scientists still believe there is an explanation for the cosmic variation. Solving black voids would be easier if we somehow have a way to go back in time to see how things began and how these voids came to be. But sadly, even with our space history teller, the CMB, dark voids remain elusive. Our universe is made up of countless galaxies, stars, planets, asteroids, and other celestial bodies. But there's a unique aspect of the universe we often overlook: the light. Not just any light, but the very light that started it all. In fact, thanks to this light, cosmologists can get so much info on how things were in the universe millions or even billions of years ago. This light is known as the cosmic microwave background, CMB. The CMB is the light that spread out after the Big Bang. It is cosmic microwave radiation that fits all of space. You can call it the afterglow of the Big Bang. The Big Bang is the event that gave birth to the entire universe as we know it. This event, according to science, happened 14 billion years ago. Just like the name implies, the Big Bang was a massive explosion that led to the creation of everything in the universe. As the explosion expanded, it began to cool down. By 380,000 years after the Big Bang, the universe had cooled well enough for the first atoms to form. Think of how a typical bomb explosion would be extremely hot at the core of the eruption, but as it diffuses into the air, everything cools down until it gets completely cooled. That's what played out with the Big Bang. When things had cooled down, light was then able to travel freely through space. This light is what we see and observe today as the CMB. It was first discovered in 1965 by two radio astronomers, Arno Penzias and Robert Wilson. At the time, these astronomers were studying radio waves in space, and coincidentally, they discovered the cosmic microwave background and shared the discovery. Today, we use radio telescopes to view and study the CMB. The CMB gives us an idea of the universe in infancy. By studying the temperature variations in the CMB, scientists can decipher a lot of information about the early universe. The CMB shows several tiny hot and cold patches. These are caused by tiny quantum density fluctuations. These fluctuations occurred when the universe was very young, but with time, they were amplified by cosmic inflation. Today, cosmologists have data and insight into the early universe, thanks to the fluctuations in the CMB. But again, just like the voids in the universe, the CMB has an anomaly too: the cold spot. The cold spot is a very large and very cold patch on the CMB, located about 1.8 billion light-years away in the southern galactic hemisphere. This cold spot is about 70 microkelvin colder than the average CMB temperature. Its radius is about 5 degrees, and its width is estimated at 490 million light-years. Just like the mysterious Great Void, several theories have been put forth to explain the CMB cold spot. One theory postulates that it is just a random occurrence with no particular significance. However, if there's one thing we know about science, it is that everything happens for a reason. Another theory was postulated that the cold spot was caused by a supervoid, something like the Great Void we talked about earlier. But there were too many questions in this theory, and so it too didn't fully explain the cold spot issue. What's most puzzling about the cold spot and other supervoids in space is that they do not contain dark matter. The absence of dark matter in these supervoids has led to a unique and controversial theory, one which seems out of the box and appears to explain the inexplicable cold spot. It's the theory of a parallel universe. You see, an astronomer named Tom Shanks suggested that the cold spot was formed by the collision of our universe with another. And so, the cold spot may be the one true evidence we need to prove that the multiverse theory is true. Recent images from James Webb have shown that trillions of stars have disappeared. In other words, you can say the void is expanding. And guess what? That may just be the beginning. This is because the space between us and the distant galaxies is expanding. This implies that the universe is still expanding. And so, eventually, not only will we be unable to reach these galaxies, but we'd also be unable to observe them, even on powerful telescopes like the James Webb. This is because their light will no longer be able to reach us here on Earth. You see, the concept of light from stars is very important in space. The stars you can see in the sky are those whose light rays are strong enough to travel through the billions of miles in space to get to us here on Earth. It's very possible the stars that disappeared from the James Webb drifted further from the Earth so much that the James Webb could no longer pick up their lights. This drifting was caused by the expansion of the universe. The concept of the universe expanding was first brought to light in the 20th century by an astronomer named Edwin Hubble. This theory of the universe expanding soon became generally accepted. However, in the late 1990s, scientists found out that the expansion was growing at an alarming rate. They drew this conclusion while observing supernovae, exploding stars that emit a certain amount of light. Before this time, it was assumed that the force of gravity would eventually slow down the universe's expansion. On the contrary, the expansion accelerated. Scientists believe this acceleration was brought about by dark energy. Dark energy is the secret force that opposes the force of gravity. It's been responsible for the pulling apart of the universe since the concept of universe expansion was revealed. It's one of the mysteries of cosmology and is studied side by side with dark matter. If you're a fan of sci-fi movies, you've probably heard about this strange natural matter. It's very different from dark matter, but they are both very crucial to the existence of our universe. While dark energy is a force, dark matter is actually matter, meaning it has mass and occupies space. Scientists believe that understanding more about dark matter and its role will lead to a better understanding of the universe as a whole. Dark matter is the invisible matter that makes up most of the mass of galaxies and space. Dark matter forms the galactic threads that structure the universe. This is why the universe appears like an interwoven thread. It's also believed that the concentration of stars near galaxies is all in response to dark matter. Having trillions of stars disappearing is quite discomforting, given the fact that scientists haven't yet come up with a clear explanation for this situation. One can't help but wonder if these same things can happen in our galaxy too. One possible reason could be the expansion of a highly developed civilization. Imagine there's an advanced alien civilization out there that seeks to expand its territory, just like we seek to live on Mars, and somehow every time they expand, it leads to the death of a couple of stars. If you think this is impossible, you may have to think again. A highly advanced gadget like a Dyson sphere could siphon the energy of stars and channel it to the operators. As strange as this idea may sound, it may very well be the answer to this strange turn of events. But the real tragedy would be when stars begin to disappear in our own Milky Way galaxy. You see, some scientists now believe that the Earth is inside a supervoid about 2 billion light-years across. The supervoid housing the Earth is called the KBC void, but since this fact contradicts some things we know about our galaxy and space, it isn't generally accepted in the science community. If, however, we are in a supervoid, or there are advanced alien civilizations expanding, the threat of the disappearing stars will soon become a reality for our galaxy, and we'd have to figure a way out fast. Otherwise, it'll only be a matter of time before nothing remains.